All right, hello and welcome to 16.5, talking about curl and divergence. And I'm going to explain on page 3 of the notes kind of the differences between curl and divergence. And I gave you a little explanation earlier in class, but when we're talking about curl and divergence, curl of f is going to be just the vector partial r over partial y minus partial q over partial zi plus partial p over partial z minus partial r over partial xj plus partial q over partial x minus partial p over partial yk. And we introduced the vector differential operator del as, so del is an operation. So usually we see del, we think of, del of f. Del of f is just the gradient. So again, del f is just the gradient. Well, when we're talking about in del, that's just the operator, all del is doing is that it is taking the partial derivative through whatever, vector we have. And so we're taking the partial derivative of x with respect to I. So, the partial derivative of the x component for I, the partial derivative of y for that, y or j component, plus the partial derivative of z for that component that's with k. So usually the z component. And so we're just taking the partial derivatives of each part of our vector with respect to, our variable x, y, and z. It has meaning when it operates on a scalar function to reduce the gradient of f. And again, we talked about the gradient of f. And so it's just, we take the partial derivative of our function with respect to x, y, and z corresponding with the component I, j, and k. So if we think of del as a vector with components, partial with respect to x, partial with respect to y, and then partial with respect to z, we can also consider the formal cross product of del with vector field as follows. And so the curl of f is just del cross our vector field. And so that's going to give us the curl of our vector field. And what we'll be able to do is we can rewrite this as basically the determinant in determinant form, where I, j, and k are components. And again, if we're doing component I, then we do the cross product of those two values. And so these two values, the cross of r with respect to y minus the cross of q with respect to z. So we're just doing the determinant there. And so that's just an easier way of remembering what the cross product form is. You don't have to, again, you have your notes, so you can just remember this formula if you'd like, but again, you don't have to remember the formula because you have your notes in front of you. This class is open notes in this form. That, because we're doing online learning and everything. But here's a faster way of understanding and learning or remembering what the curl of f operation is. And so all we're going to do is find the curl of the vector field. And so again, we're writing this as, the cross product of del and f. When we do that, we're just plugging into the formula. So we plug into the formula the partial derivative of that function with respect to y is going to be just inverse tangent of x over z, minus the cross product of, minus the product of, or just the partial derivative of e dx sine z with respect to z. So derivative of sine of z is cosine z, so e dx cosine z is what we're going to get for that first part, or the I component of our vector, all right, or the x component. Second part, again, we're finding j, so we're taking the cross. So I put a negative in front because I'm doing it using the determinant method. And so the derivative of this function with respect to x is just going to be, y times 1 over 1 plus x over z squared times 1 over z. And it's going to reduce to this form because what I'm going to do is, instead of making it 1 over z, I'm going to say, that's just going to be z over z squared. And multiplying it by that, I'm not changing it. I'm just changing the way that it looks. I'm not changing the actual value of that. Just so I can have a nice clean answer right there. All right, and then the last part, just taking the partial of, we're finding the k component now. So taking that partial e to the x sine z with respect to x. So that's just going to be y e to the xy sine z, and then taking the partial there of 0 is just going to be 0. And so this is what we're left with. I'm going to hit redo because something happened, and I don't even recall what I changed on here. All right, and that gives us the curl